Functions are often denoted by the letters f, p, c, g, and so on, but f is the most common, you'll see. If f is a function, then for each number x in its domain, the corresponding value in the range is denoted by f of x. This notation is read as, again, as I've said before, f of x. So when you have this here, you read it as f of x. It is not f times x. And just so you should know, when they say f of x, we're just saying y. So if you have y equals something, you can just call it f of x. If you have f of x, you can just say it's the y value. So more often than not, you'll see f of x representing functions. It's just another way of saying y. So let's go with the first one. We're going to evaluate some functions. So we have f of x equals 3x plus 1, and we're going to evaluate for f of 0. So f of x is in the parentheses, but here we have 0 in the parentheses. So what we're going to do is we see that since x has been replaced with 0, we're going to replace all of the x's inside our function with 0. So we're going to get 3 times 0 plus 1. And then we're just going to evaluate it. 3 times 0 is 0, plus 1. And then 0 plus 1 is 1. So f of 0 equals 1. I'm going to do it again. We have f of negative 2. So anywhere there's an x inside of our function, we're going to replace it with negative 2. So we're going to get 3 times negative 2 plus 1, which is going to be negative 6 plus 1, which will come out to be negative 5. So f of negative 2 is equal to 5. But we are not limited to just numbers. We can even put letters inside the function. So we have f of k, and so let me write the function here. F of x equals 3x plus 1. So wherever there's an x inside of our function, we're going to replace it with k. So we're going to get 3k plus 1. All we're doing is just substituting it out. You can't do anything with this, so f of k equals 3k plus 1. And last, we have f of m plus n, which means wherever there's an x in our function, which is right next to 3, we're going to replace it with m plus n. So we're going to get 3m plus n plus 1. We can distribute the 3 inside, so we're going to get 3m plus 3n plus 1. And we have no terms we can combine, so we can say that f of m plus n is equal to 3m plus 3n equals 1. Now, what about a linear function? Or we've just done a linear function. What about a quadratic function? We have g of x equals negative 2x squared plus x plus 1. We're just going to do the exact same thing. Wherever there's an x, we're going to replace it with what's in the parentheses. And inside our parentheses is a 4. So we're just going to replace it with 4, all our x's. So negative 2 times 4 squared plus 4 plus 1. 4 squared is going to be 16. 4 plus 1 is going to give us 5. Negative 2 times 16 is going to be negative 32 plus 5. And then negative 32 plus 5 is going to give us negative 27. So g of 4 is negative 27. Let's do it again. G of negative 1. So wherever there's an x, I'm going to put in negative 1. So negative 2 times negative 1 squared plus negative 1 plus 1. So negative 1 squared is going to give me 1. And then plus a negative 1 is just minus 1 plus 1. Negative 2 times 1 is going to give me negative 2. Negative 1 plus 1 is 0. And then negative 2 plus 0 is just negative 2. So g of negative 1 is negative 2. Again, if we have a letter inside the parentheses, we're just going to change it out. So just write it up here, since it's kind of off screen. G of x is negative 2x squared plus x plus 1. And so wherever there's an x, we're going to replace it with p, because that's what's inside the parentheses. So we're going to get negative 2p squared plus p plus 1. No like terms to combine. So we're done. Last, g of x plus h. There's an x in there, so it makes it weird, but it's okay, because we're just going to follow the exact same rules. Whatever's inside this parentheses is going to replace all the x's. So we're going to get negative 2 times x plus h squared plus x plus h plus 1. And now we know that x plus h squared is just negative 2x plus h, x plus h. And then we don't need the parentheses here, so we can say plus x plus h plus 1. And then we're going to FOIL out or distribute our binomials. And we're going to get, when we do that, x squared plus xh plus xh plus h squared plus, running out of room, x plus h plus 1. And then we're going to distribute the negative 2 in and combine like terms. So when we do that, we're going to get negative 2x squared minus 4xh minus h squared plus x plus h plus 1. And as ugly as this looks, there's nothing else we can do with it. So that would be our final answer for g of x plus h.